The next question is an important one from Mariska, and that is about the fourth industrial revolution, which is a very hot topic at the moment. And I'm going to ask Dr. Linda Iaccheri to answer this question. And it relates to what high-tech equipment or 4IR technologies might I be exposed to as a student in geosciences? Over to you, Linda.
Thank you, Grant. Yes, a very interesting question. I'm glad it came up. The Earth is a big system. I hope that you can see me. And you can look at the Earth from the space, and you can use satellite images and look at the surface of the Earth and monitor the structure. Actually, through the satellite images, you can also look out into the space, because when you are going to get to know the Earth, there may be all the information that you are going to gain. You can also apply to the other planets in the solar system. As Subea mentioned, actually, geology is a very multidisciplinary approach. But going to the satellite, okay, you can look at the surface of the Earth, and then eventually you have to go into the field if you want to gain more information on what is outcropping. And sometimes geologists, they go out, they can map rocks and see which kind of rock. And in the past, they were making beautiful handmade analog map. Now you can go in the field and have a pad and right away type all the information about the rock that you see. You have also a portable XRF machine that is like a little gun. You can shoot on the rock, and on the spot, you can have the chemical composition of the rock. And this information, since they are on a pad, you can send directly into the office where your colleague can start to work on this data while you are still in the field. But the Earth is not only the surface, it's not only the atmosphere, it's actually the inside of the Earth. And the diameter is thousands of kilometers, and we cannot really reach into the depth ourselves. We can drill. We heard that there is a major drilling program. So the drilling program is just when a very sophisticated engineering machine is drilling and making a hole into the ground and take out on the surface samples, so you can see what is outcropping below your feet. But this drilling program are usually only hundreds of meters. The Earth is much deeper, so we need to use indirect ways to understand what is the structure of the Earth. And Sue before was mentioning about geophysics, that is using the property of rocks to study the interior of the Earth. We heard about earthquakes. Some rocks are hard, some rocks are soft, and they are going to delay or accelerate the arrival of the waves. And in this way, you can make map of the interior of the Earth just because of the velocity of the waves of the earthquake. Rocks are also sometimes magnetic, and so you can make maps from magnetic property of the rocks, and you can see if at depth in an area that you cannot reach, there are rocks that are more or less magnetic. And rocks are also conducive for electricity. So if you are putting electricity in the ground, eventually you can also map and discover what is below your feet using these physical properties. And then there is another field that we spoke about, and especially Glenn mentioned, is geochemistry. That is a field that is in geology, but is also overlapping with the chemistry, where you are going to use the chemical properties of a rock. And what is this? The rock is made of minerals. The minerals is the building blocks of a rock. So if you want to see in specific what a rock is made of, we saw in the video that they are cutting the rocks and making very thin layer, and you can look at the rocks through a microscope and eventually identify all the single mineral that the rock is formed. And this is going to give you an information where the rock formed, if it were deep in the earth or more on the surface. But the building block of a mineral are actually element. And so you can do a chemical analysis of this element. And in particular, the element are going to give you some information again, how deep is the rock formed, or there are some elements that are in very small concentration. We call them trace element. And these elements are going to tell you what actually happened to this rock, what was before the rocks. And in particular, we have a very sophisticated lab. It's a very clean lab. There is, before in the video, there was Kulokani that has an overall and a mask, because the lab is without dust, is super clean. And in that you can have measured the concentration of very tiny mineral or very tiny element in very small concentration. This gives you the idea of older rocks. So when the mountain formed, how the mountain formed, did the melt was much deep, and what was melting. So these are information to understand how the earth evolved, how the continent grew with time, and eventually what is going to happen in the future. Thank you.